Hi girls, so we're going to be looking at some questions regarding x values for functions increasing or decreasing or greater than or equal or greater than or less than 0. So if we look at this question, we are given a parabola given as f of x equals negative 2x squared minus 4x plus 30 and a straight line given as g of x equals 2x plus 10. Now for the purposes of this video, we are not going to do all the previous questions that would have come in this question. For example, there are questions like determine the coordinates of a and b, the x-intercepts of the parabola, determine the y-intercept of the parabola, which is c, determine the points of intersection of f and g, that would be points a and e. So I'm going to give you those so that we can work with the question that we're focusing on now. Okay, so for this question, we're going to assume that we've answered the coordinates on the right hand side there. I've only put the 3 that you'll need for the questions I'm going to be dealing with. Question A, for which values of x is f of x less than 0? So firstly, determine which function you're working with. We're working with f of x, which is the green function that I've highlighted in green. But they want to know particularly when is that f of x less than 0? In other words, when is y less than 0? So the y values that are less than 0 for function f is this portion and that portion. All right, once we go above into this portion, we're above 0, we're greater than 0. So how do we write that down? We need these two coordinates at a and b. So we can see that for the values of x that are less than a, look where the arrow is, for the values of x that are less than a, this parabola or f of x will always be below the x-axis. And for values of x that are greater than b, this parabola or f of x will always be again below the x-axis so that the y values are 0. So the way that we write this down is that we're going to say x is less than the x value at a, which is negative 5, or x is greater than the x value at b, which is positive 3. We don't use a less than or equal sign because in the question it said it must be less than 0, not less than or equal to 0. Question B, for which values of x is g of x less than or equal to f of x? All right, so firstly, let's look where g is. G is this graph here, the straight line graph. And let's look where f of x is. Again, I'm going to use green for the f of x. Now they're asking, when is g of x less than f of x? Or in other words, when is g of x smaller than or equal to f of x? Now remember, we're talking about y values here. So they're asking for which values of x are the y values of function g less than or equal to the y values of function f. Another way of saying it is when is the g graph smaller or below the f graph. I'm sure you will agree that this portion that I'm highlighting in green now is when g of x is less than f of x. Okay, so let's understand why. For the whole portion that I've highlighted in green, the f graph is above. In other words, the y values are always going to be more than the g graph values. Whereas if we look to the left here, where I haven't highlighted, in this case, g of x is above f of x, which is below here. And in this case, on the right-hand side, g of x is also above f of x. So for those two cases, that would be when f of x is smaller than g of x. Right, so how do we write this down? Firstly, look at the instruction. They've said that is it less than or equal to. That means that at the points A and at the points E, those 2 points are valid. Those x values there are valid because those two graphs are then equal to each other at that point. So in other words, the number line that we're looking for is from this x value to this x value, which is the same x value at point E. Right, so we're including both of those. So in this case, it goes from point A, which is negative 5. It includes point A at negative 5. So we use the less than or equal to x, which is less than or equal to the x value at point E, which is positive 2. Question C, for which values of x is g of x greater than 0? So again, we're looking at g of x, which is now the straight line. When is it greater than 0? Remember that 0 is here, and anything greater than 0 is on the y-axis positive. So that means we're actually only dealing with the straight line that is above the x-axis, and it stops here at point A. After point A, it goes below the x-axis, and the y values are then negative. All right, and because it's a straight line, we know it's not going to change direction, so it goes to infinity in that direction. So for all x values to infinity, this graph of g of x will still be always positive, and in fact, it'll be getting more and more positive because it has a positive gradient. So how do we write that? We need the x value at point A, which is -5, and if we look again here, they are saying when is it greater than 0, so it's not allowed to equal 0, so we would now say for our solution that x is greater than -5. For any value of x greater than -5, g of x will be above the x-axis, and for any value less than -5, g of x would be below the x-axis or less than 0. If x equals -5, then g of x will equal 0 because it will be on the x-axis itself. Right, question D, for which values of x is f of x increasing? So now we're looking at the parabola. For this question, you'll also need the coordinates of g, which you would normally have worked out in a previous question. In this case, they are -1 and 32. Right, for which values of x is f of x increasing? If we have a look at the graph f, it starts off on the left here with an increasing gradient all the way until it gets to the turning point. After the turning point, the gradient starts to decrease. All right, goes in a negative gradient. So they're asking when is f of x increasing? So in other words, they actually only want this portion of the graph, stopping at g, because from g onwards, it starts to decrease. All right, and because we know it's going to negative infinity in this direction, the x values will also go to negative infinity. In other words, the more x travels to negative infinity, or the further it gets away from 0, the further the graph is going to decrease. So how do we write this? We look at the x value at point G, and we're looking for all the x values to the left of point G. So we would say that x is less than -1. Because any value greater than -1, the graph will begin to decrease. Let's just look briefly at the straight line function. If the question was asked for which values of x does g of x increase, we can see that it's a straight line and it's increasing for all values of x, okay, to positive infinity and to negative infinity. Any x value that you use here, the graph will be increasing. So we would say x is an element of all real numbers. If they'd said, when is g of x decreasing, we would say that there's no solution. There are no values of x that would cause this graph to decrease. In other words, there's nowhere that this graph is decreasing.